This question is from GATE 2018 Mechanical Engineering paper set 1, question number 31. A carpenter glues a pair of cylindrical wooden logs by bonding their end faces at an angle of theta equal to 30 degree as shown in the figure. The glue used at the interface fails if criterion 1, the maximum normal stress exceeds 2.5 megapascal, criterion 2, the maximum shear stress exceeds 1.5 megapascal. Assume that the interface fails before the log fails. When a uniform tensile stress of 4 megapascal is applied, the interface, option A, fails only because of criterion 1, option B, fails only because of criterion 2, option C, fails because of both criteria 1 and 2, option D, does not fail. Basically, in this question, we have to calculate the actual maximum normal stresses at this plane, because they are saying that the log fails after the interface fails. Interface is going to fail first, and therefore we have to calculate the maximum normal stress and maximum shear stress at this interface and then compare it or see whether it is less than or equal to the strength that is given. If it's less than the strength given, it is going to fail. For each of the criteria, we have to check this and see what criteria is applicable at the failure. Let's do it. Now, this is a question of transformation of stresses, and one should know that if on an element a particular plane is given to us at any angle theta, we should know that when this element is subjected to a stress value, how much will be the maximum normal stress and maximum shear stress on this plane at angle theta. If we want to calculate the normal stress on this plane, it will be sigma normal, because it's the normal stress, will be equal to sigma cos square theta. So first, in the derivation of sigma n, first the forces are being calculated using the stresses, and then the forces are transferred on the plane, and forces are then back calculated to stresses. That is how this formula is derived. But for the exam, you should remember the standard formula for transforming uniaxial stresses on planes inclined at angle theta. This theta is taken with the vertical. With respect to this plane, the theta is being measured. Similarly, the maximum shear stress, tau, for this particular plane, let's write it as tau theta, will be equal to sigma, this normal stress, into sine 2 theta by 2, gives us the maximum shear stress on this plane. So on this plane, basically, if we look at it, this is sigma n and this is shear stress. Direction of the shear stress depends upon whether it is what type of stress is applied. Normal stress, here it is tensile. Therefore, I have shown tensile stress. It can be compressive also. So let's calculate for the given case. We have maximum normal stress on this plane inclined at 30 degree will be equal to 4 MPa is the stress value at face into cos square 30 degree. So sigma n will be equal to cos 30 is root 3 by 2. So it is 4 into root 3 by 2. Don't forget to take the square, which is equal to 2 square is 4. 4 by 4 gives us 1 and root 3 square is 3. So it is 3 megapascal. Now, as it is given that as per criteria 1, maximum normal stress should not exceed 2.5 megapascal, otherwise it will fail. So this is exceeding 2.5 megapascal. We can see that here, and therefore by criterion 1, failure will occur. That we have checked. But we will also have to check for criteria 2. So let's calculate the maximum normal stress, maximum shear stress tau theta. It will be equal to 4 into sine 2 theta, that is sine 2 into 30 by 2, which is equal to 4 into sine 60 degree is again root 3 by 2. So it is root 3 by 2 whole divided by 2. This again turns out to be 4 by 4 1 and root 3 remains. So maximum shear stress on this plane inclined at 30 degree on this interface is root 3, which is nothing but 1.732 megapascal. So as per the criteria given, this is greater than 1.5 megapascal. We see that here also, according to criteria 2 also, failure will occur. and therefore the interface is going to fail by both criteria 1 and criteria 2. Let's go back and mark the correct option. Option C is the correct one. The interface fails because of both criteria 1 and criteria 2. To learn more about analysis of stress or transformation of stresses and strain to a particular plane inclined at theta, you can refer to the NPTEL video Analysis of Stress 1 from the course Lecture Series on Strength of Materials. This course is by Professor S.K. Bhattacharya. He is from Department of Civil Engineering of IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.